we are going to discuss about the atomic spectra, which is the, you can say, which gives the quantized behavior to the electronic state of the atoms. Okay, now the atomic spectra. So before we go to the atomic spectra, what is the spectrum? It is the, we can say, the band of the 7 colors which has been obtained, right, when a white light is made to fall on the prism. So by the phenomena of the dispersion, the splitting of light will take place and we get a band of 7 colors, right? And here there is a increasing order or the increasing arrangement of the light in terms of the wavelength, or decreasing of the frequency. Now this is when we have the white light, but in case of the atoms, right, in case of an element, we get the atomic spectra. Now whenever an element is being heated, right, it has been heated, but we can either directly heat it or we can pass the electric current or electric discharge through the discharge tube. What happens then? The element which is present in the gaseous state, it is going to absorb that radiation, right? It will get excited up, and when it get excited up, you know that the excited state is always an unstable state. It will just try to come back to its original state by emitting out the radiation. Now the radiations which are being emitted out, they will fall through the slit, will made to fall on the prism, and we will get a, we can say, we will get a spectrum obtained. Right now, this spectrum which has been obtained is obtained on the photographic plate, and when it has been developed, we get the different lines, right, bright lines obtained. Now these bright lines, they are characteristics of the element. Now you can see in the diagram here that the atomic spectra, this is why we are calling it atomic spectra, because the spectra is a characteristic of the element, right, and then element what we are considering the atom. So atomic spectra. Now the atomic spectra is obtained, why? Because of the energy changes which will take place in an atom. That's why the spectrum obtained is known as the atomic spectra. Now the atomic spectra is divided into two types. It can be emission spectra, it can be absorption spectra. These are the characteristic of an atom. Now when we get the emission spectra, when the atom will be excited up. Now, as I said, that we have taken a discharge tube, right? And here we have kept an element in its gaseous state, whose spectra is to be obtained. So, when an electric discharge is made, right, what will happen? That elements, atoms are going to get excited up. Now, in excitation, they will again try to come back to the original state. For that, they are going to emit out the radiation. Now, those radiation are made to fall through the slit on the prism. Dispersion will take place, right, and we will get the radiation splitted up into different, we can say, the colors, right, of different wavelengths. Now the photographic film, when it has been developed, what is observed, that we get the bright lines obtained. Now these bright lines are separated by a dark zone, there is a dark band, and these straight lines are indicating the bright line. Now let us take an example here, that if we have taken sodium, right, we want to get the spectra for the sodium. We will take the sodium element here, right, its vapors will be kept here. Now when the electric discharge will be made, the light which has been radiated out, or radiation which is coming out, is made to fall on the prism, and we will get the bright line, right, we will get the bright line at the wavelength at 589.0 nanometer and 589.6 nanometer. So students, between these two wavelengths, we will get the bright lines, and that line color will be yellow, right? So we get a yellow lines, the bright color yellow lines, where at this wavelength, right, at the wavelength this region is there, we will get the yellow lines there, and rest part will be the dark region. So I think this is clear that the emission spectra is obtained when the element at its atomic level is excited up, right, and then we get the radiation emitted out, and those radiation, when it made to form the prism, and then the dispersion will take place, it is going to split up, and when this lights have been this spectra is obtained on the photographic film developed, we will get the bright lines. Now student, one thing more, that why it is called atomic spectra, because the energy, the spectrum is obtained because the energy changes taking place at atomic level. That's why it is known as the atomic spectra. And the emission spectra is known as the line spectra also, because here we are getting the bright lines. This is a line spectra. And one thing more is there, that atomic spectra is the characteristics of the particular element. So that's why it is known as the fingerprint of that particular element also. Discuss now the emission spectra. Now will just move ahead. We will discuss the absorption spectra now. Now, when a continuous light is made to fall on the substance in its vapor state or in the solution, it is going to absorb a part of the, we can say, light. And when the further light, that's a transmitted light, is made to fall on the prism through the slit, the dispersion will take place and the remaining part of the light is going to split up and we will get the spectrum obtained. Now there is a difference in the spectrum obtained from the emission spectrum. Here we are going to get the dark lines. Earlier we were getting the bright lines. Here we are going to get a dark lines, and in between the dark lines we will have the bright band. Right now, what does this dark line indicating? This dark line is indicating the corresponding wavelength which has been absorbed by the substance, and it will be characteristic of that substance at which color wavelength it is going to absorb, at what frequency or at what wavelength. Right now you can see here in the diagram that absorption spectrum, we have taken here the source of the light through the slit. This is slit here, right? So in this, we can say the container we have placed vapor or the solution of the substance whose absorption spectrum we want to obtain. Now when the radiation source, the light source, continuous source of light is going to fall on this solution of the vapors, right, the light which is further transmitted is made to fall on the prism, and then it is obtained on the photographic plate, and then when it is being developed, what we are getting here? We are getting here the dark lines. Here I have shown here the dark lines, and in between the dark lines we will have the bright bands. The bright band means here the colored band you will going to get. But in the dark lines it is showing that a particular wavelength of the light which has been absorbed by the vapor or the solution of this particular substance, here we will not get the color. Here we will get the dark line. Right, so this is the absorption spectrum. Now let us again take an example of here sodium, that if we have taken here the sodium vapors or we have taken NaCl solution, right, so when this light, continuous light will be made to fall over here, and then the further transmitted light will be fallen on the prism, and then on the photographic plate we will obtain the spectrum. When it is being developed, we will get the dark line here at the same place where we were getting earlier the colored line, yellow line, right? That was, I'm showing it here because we have got particular here that we'll get a dark lines here at 589.0 nanometer, 589.6 nanometer. That means this is 589.96 nanometer. That means we will get the dark lines at 589 and 589.6 nanometer if we have taken sodium or the sodium chloride solution in this container or in this chamber, right? So it indicates that we will have the lines obtained at the same wavelength as we are having the bright colored line in the emission spectra.